All right, today we are diving deep into a really fascinating peptide called thymosin alpha-1. Now, you've probably heard it mentioned for immune health, but we're going to go way beyond the buzzwords and really get into the science of how this thing actually works.
You hear that phrase all the time, right? Boost your immunity. But think about it. Is a sledgehammer really the best tool for the job? Your immune system is this incredibly complex, finely tuned orchestra. Just cranking up the volume on every single instrument isn't going to create a symphony. It's just going to create a whole lot of noise. So today, we're going to explore a much smarter idea: immune modulation.
So, if just brute force boosting isn't the way to go, then what is? Well, that's where thymosin alpha-1 comes into the picture. This isn't some synthetic drug. It's a natural peptide that our own bodies produce to act as a kind of master modulator for our immune system. And that word, regulate, is absolutely everything here. See, an immunomodulator doesn't just put the pedal to the metal. It's more like a conductor, helping to coordinate and normalize the entire response. It makes sure your immune system is powerful when you need it to be, but also tells it to quiet down when the threat is gone. So what exactly is thymosin alpha-1? Well, at its core, it's a small but mighty chain of just 28 amino acids. It was first discovered in the thymus gland, which you can think of as the boot camp for your body's most elite immune cells. And because our bodies make it naturally, it knows exactly which buttons to push, interacting with key signaling pathways like toll-like receptors to give our immune cells very, very specific instructions.
And that brings us right back to our orchestra. If the immune system is the orchestra, how exactly does thymosin alpha-1 act as the conductor? Let's get into the nitty-gritty of how it really works.
Okay, think about the difference like this. A simple booster is like turning up the volume on everything at once. It's just chaotic noise, and it can actually lead to unnecessary inflammation. But a modulator, like TA1, that's the conductor, making sure every section plays its part perfectly in sync, creating a powerful, coordinated, and balanced response. So how does it pull this off? Well, first, it makes sure the musicians, our key immune cells, are fully trained and ready to go. Then it hands out the sheet music by increasing the production of these little signaling molecules called cytokines. But, and this is the most important part, it balances the entire performance, making sure it's powerful but never, ever spirals out of control into chaos. And who are the star players in this orchestra? We're not talking about just any cells. TA1 specifically targets the immune system's A-team. You've got your helper T cells that coordinate the attack, your cytotoxic T cells that are the assassins, your natural killer cells that provide that super fast first line of defense, and your dendritic cells, which are like the spies, gathering intel and telling everyone else who the real enemy is. Okay, this all sounds great in theory, but where's the actual proof? Well, the story for TA1 really got started in the lab, with those crucial preclinical studies that first put these ideas to the test. And you know what? The early evidence was pretty compelling. Get this. In mice that were literally born without a thymus gland, TA1 was able to restore their immune function. Then, in animal models of cancer, adding TA1 to things like chemotherapy actually improved survival rates. These were the green lights that really paved the way for human trials. Which, of course, brings us to the most important part of the whole story: the human data. How does thymosin alpha-1 actually perform when you put it to the test in real people in the real world?
TA1 has been studied in viral infections for decades. Some of the early trials showed it could help improve immune markers in people with chronic hepatitis B and C when it was added to their standard treatment. More recently, during the COVID-19 pandemic, some studies found it helped improve T-cell counts, but its effect on whether patients got better overall was, frankly, a bit less clear. But what about a situation where the problem isn't a weak immune system, but one that's gone dangerously haywire? That's sepsis, a life-threatening immune system meltdown. And here, in a huge meta-analysis, researchers found that TA1 was actually associated with a reduction in mortality. This really highlights just how critical its regulating job can be. And the number they were looking at was 28-day mortality. That's a critical benchmark in intensive care. The data showed a significant drop for patients who received TA1. This is a really powerful sign that its ability to rein in an out-of-control immune response can literally be a matter of life and death. Now, maybe the single most studied area for TA1 is as a helper or an adjunct in cancer treatment. We all know chemotherapy can really knock down the immune system. So the idea here is that TA1 can help restore the body's natural ability to fight back and to police for any remaining cancer cells. But we have to be really precise and honest about the results here. The scientific literature puts it perfectly.
TAT1 often showed positive trends toward better response rates and survival, but it didn't always hit the main primary goals of the studies. And that just goes to show you that its benefits can be subtle and really depend on the specific situation.
And look, we are not talking about a handful of tiny studies here. A huge, comprehensive review of thymosin alpha-1 covered more than 30 different clinical trials and over 11,000 people. That is a massive body of evidence that's been built up over decades, which is pretty rare for a peptide like this. Okay, so after all this research, what's the bottom line? Let's pull it all together and talk about its safety, its limitations, and what the future might actually hold.
Across all of that research, one thing has been remarkably consistent. TA1's safety profile is really, really good. For the most part, it's very well tolerated. The most common side effects are mild, manageable things, like a little bit of a reaction where it's injected, or maybe some temporary fatigue. But of course, even after decades, science is never really done. There are still some really important open questions that we need to answer before we can say we fully understand TA1's potential.
For example, researchers are still trying to figure out exactly where TA1 fits best with today's super advanced cancer treatments. A huge question is whether it can boost the effectiveness of newer immunotherapies, like checkpoint inhibitors. And the holy grail, really, is to find a way to predict ahead of time which specific patients are most likely to get a benefit from it.
And that leaves us with this one last thought to chew on. We started this whole thing by questioning that simple idea of boosting immunity. But after looking at the science behind thymosin alpha-1, the real question becomes, could the precise, intelligent act of regulating our immune orchestra actually be far more powerful than just making it louder?
This explainer was brought to you by InfinityPeptide.com. Thanks so much for tuning in.